Today we are talking about statistical estimation and forecasting. What is statistical estimation? By mere thinking of estimation, we are looking at an idea. You want to anticipate a value. That is estimation. But when we attach to statistical estimation, we are now looking at the mean, the standard deviation, the variance as a statistical tools for the estimation. So in this course today, we are going to discuss what is statistical estimation and forecasting. And the forecasting aspect of it is talking about prediction. What are you predicting? How do you predict? Then, can I give you a simple example? We will talk about estimation. Someone will tell you, give me an estimate. That is an idea. Give me an idea of what is involved. The essence of doing that is for you to get closer to the actual value or to get your budget correct or closer to the budget so that you will not run out of cash or run out of the expense of the budget when you are executing a project. So that is estimation. So when you talk about, if we are to define the statistical estimation as it is, we say it's a statistical inference that involves the process of making judgments about a population based on sampling properties. So what he's talking about, when you go to a market, I want to get a price of different items or a price of a particular item from a given company. What you do, you pick some prices from the market, from different markets or from the same market, from different customers. What you are doing, you are trying to get a sample of that. And by the time we ask you, what is the price of a particular product? You say, it's 6. That's a particular value. You just generalized the value by estimate. What you did is to get the values and get the mean of that value. And when you get the mean, you discover that that mean or the average, as the case may be, is an estimator to the entire population, to the entire products you have in the market, or to the price of what you have in the market. So what you're actually doing is trying to estimate something with a sample. The population is a large thing that you cannot collect the whole data and start working on it. But when you collect a sample of that population, then you get that sample, work on it, get an estimate. That single value is an estimator. You estimate based on what you have gathered, and you are now saying, this is what it is. Based on that, you can now generalize, say, the price of a particular item in the market is this. Someone will ask you, what is the price of this in the market? What are they selling these things? Is it the cost? The essence of doing this is to get you closer, to know whether the price is making you not to sell your product, or the price of other products are higher or cheaper that makes you not to sell your product. So in this essence, you are trying to get these things, estimate it. Okay, can I have an estimate of what is going on in the market as regards to the price? Then you quickly get to the market, get the price of those things, and discover that these prices are in order. So when you say that the price is unbiased, it means that you are working with a price that is unique. So that is, we now talk about point estimation and interval estimation. The point estimation is talking about a single value that you estimate the value of the population parameter. A single value. When you talk about point estimation, you are talking about a single value estimate of the population parameter. So you talk about the population. The population is generality of the whole thing in that market. But when you pick a single value and say this is the estimate, that means if you are say 50 naira is the estimate of a particular product, that means if you get the whole product as regards to that company on that particular item, product line, what they are selling in that market, you are estimating the total population price as 50 naira. That is point estimation, or 50.5. That means a single estimation. That is how we get the point estimate. Then you have another one, interval estimation. This one gives you a range. The price ranges from 50 naira to 100 naira. That is varies. We are now talking about variation interval. 50 to 100 naira or 100 naira to 200 naira. That's a range. Between that 100 naira to 200 naira, there could be 110, 105, 120. So by the time you get to 200, that's an interval. So if you want to put it, you now see price from 110, 100 naira to 110, 110 to 120, until you get to 200. That's an interval. And we use this as an estimate when you are doing all these things. So in that point estimate, we now talk about how do we get these things done in a proper way. So we say that it must depend on a sample, not on population. When you want to do a point estimate, you'll be looking at a particular sample. That sample is what you are going to base your estimation. When you get that X1, X2, X3, X5, up to 10, those samples, variables you have collected as estimates, you value them, get a sum of it. When you sum it up, you get a value and divide it by a particular value, then you get a mean value. And we are saying that this mean value of the sample is equal to the population estimate. So you are using that mean to estimate what is involved in that area. Supposing in the production line, when you get to the production line, if you don't care about these things, you make mistakes, because somebody will ask you, what's the range of the damages you experience in this machine? You say you don't know. It looks like you are not doing the correct thing. What you need to do is to, each day in the week, you gather the data. This is 10 damages, 20 damages, 30 from this particular machine. As you are taking record of all these things, at the end of the week, you have an estimate. You divide it and get a particular value. And that value you get, you say, in a week, we have a mean value damage of given product from this machine. Therefore, on that thing is giving you confidence that this machine is not performing well, or this machine is performing well. These are the things the estimate is helping you to do. It help you to get closer to actual thing you are doing. So when you do this, you're able to gather your information and analyze this information, analyze the data. Then from there, you report to the management, this is what we are happening to this machine in terms of production. This machine is not going to help us when there is a competition, or when there is a season, a summertime when there will be drinks, or when there is a season for sales. So if we are looking at this machine, it's not going to be reliable for us to achieve our targets. So by the time you do all this, you get a particular value and advise the management that this machine cannot help us to achieve our number in a particular period, especially in the season period when there's demand for those products. The machine will be breaking down or will be generating a lot of errors or damages from the things. So when you are doing this, you are doing an estimation. You are carrying out an estimation. It says it can be used in a place of unknown population. You don't know actually the exact population, but you are assuming that if you carry out this analysis, you are going to get closer to the things we are doing. That's why we are talking about interval and point estimation. So when you do that, you help the management to look at what is involved in getting the actual value or close to the value you are working with. Estimation of the population parameters like mean, standard deviation, variance, and covariance are used in doing these things. In production, you can use statistical tools to control the damages, where we have stock control, inventory controls, and some control measures that you apply in order to get these things. Obviously, estimators are bent on different true values of population parameters. So these things we are talking about, estimators, they are based on true values of the things you are doing. You get the true values from those things, and you'll be able to rely on these things. It could be divergence or differences in those things, but it may be minimal. So what you are trying to do is to estimate between a particular true value, which may be specified beforehand. So if you are trying to do an estimate, you are trying to get a value beforehand so that you're able to know where you are going. It takes you closer to what you are doing. That is the actual things involved in estimation, statistical estimations. Look at these things. When you get to production or in any environment, you say you are using 10% error. That is significant error. That is big. Said to say 10% is big, because if you are given an error estimate of 10, that all things being equal, we are going to get 10% error. That is no longer obtainable in this modern time. In this scenario, we have technological experts. We have softwares and machines that can generate results in nanoseconds. It's no longer batch process, batch system we apply in the business, because that time you batch things, do the batching process, do the analog systems, but now there's real time when you use nanoseconds to process some things. When you process all these things, you get a value instantly without wasting your time. So those values can be different, but it will not be much. When you're talking about 90% confidence, that's all things being equal, you can get 90%. Those things are obsolete as far as I'm concerned. What we are looking at now is 99%, 98%. So you are talking about 2% error margin. The significance error, level of significance in the production is 2%, 1%, 5%. In the behavioral science, what is allowed is 5% error. All things being equal, you are going to have an error of 5%, which is allowed. In the medical aspect of it, you have 99.9, that is 0.01%. That is what is expected in the medical area. Because a doctor cannot tell me I'm going to give 1% error in taking operation. That means we want to kill somebody. So what you are talking, you say 99.9, that is 0.01%. You are talking about the error you are going to do in carrying on an operation on human beings is 0.01 or 99.99%. So the percentage of error you are going to do is very minimal. That means you are sure that what you are going to carry out an operation, you are going to achieve success. The human beings will be alive, because we are not taking that for granted that you do an error or leave an instrument inside somebody's womb or body. That is what we are talking about, significant level of things you are doing. That is an estimate. You can't give an estimate that will be very biased. So in that sense, you say a good estimator is one which is close to the true value of the parameter as possible. The properties of good estimator is that estimator has to be unbiased, unbiasedness. Then you have consistency, you have efficiency of it, you have sufficiency of it. So when you're talking about the property or the conditions in which estimates can work, you look at unbiased. Unbiasedness is when you talk about that when you do something, the estimated value is assumed to be unbiased. It's not biased. That's what you are talking. You are sure of what you are getting. So you say that a statistic T with the variables of its x1, x2, x3 to xn is said to be unbiased estimate of the population parameter if the expected value, look at it, the expected value we discussed last time, if the expected value of that T is equal to mu, the population mean. That's the mean value of the sample distribution of the statistic T is equal to the population parameter mean. That's what we are talking. So when you say it's unbiased, that estimation you are doing, if you collect the sample and carry out the mean and you get a particular value, by the time we do the estimate, the population mean will be equal to that or very close to it. That is unbiased. It's not distorted. It's not digressed. There's no error. There's no mistake. And that is unbiased estimate. The statistical aspect of it is telling you that the estimate of T, the mean value of T is equal to the population mean. That is pure and simple. Then there's another estimate we can talk about, the proportion. The expected mean proportion of a sample is equals to P. That is telling you that the population proportion is equal to the sample proportion mean. So if you pick a proportion, a given proportion as a sample and take the mean aspect of it, you get the mean of it, it will give you the same thing as the proportion mean. That means it's unbiased. For instance, let the standard variation or the variation or the variance, the sample variance of a given population is S. Then when you calculate the variance, you have that, and when you calculate the variance, you discover that the variance of that thing is almost very close to it. That means the variation is not much. It's very reliable. That's what it's talking about, variance. Variance is talking about the differences we have in the actual sample, the variable minus the mean, square it, divide by the number. When you take the difference of the mean, you get a sample, get another sample, you take the mean of that sample, then you subtract all these various samples from the mean and square it. When you square them, you divide it by the number. That gives you this variance of that. The summation of that will give you a variable, a particular value, what we called variance. And that variance is unbiased estimate of the population variance. So when you talk about it, we have a sigma. A sigma is a population variance. And when you have S squared, square of S, when you carry out a mathematical calculation of this n, 1 over n, summation of xi minus the mean squared, that will give you the sample variance. And we're talking that the sample variance is unbiased when it's equal to the population variance, which is sigma. The sigma, this small sigma is telling us that the population is the same. So it provides unbiased estimate of the population variance, sigma. So when you calculate these things and divide it, you get a value. And that value is an unbiased. It's approximate to what we are looking at by looking at the sample size in that large population. So when the sample size is large, this time around, when sample size is large, ranging from 50 to 100, more than 30. We always talk about sample size is large when it's above 30, when you cannot take the entire population. So when the sample size is large, what you are going to do now, instead of n 1 over n, you have 1 over n minus 1. You sum the variables in that. Xi minus the mean of that variable squared, you get the sample. That is when the sample size is large. Then you get the population. And we are saying it's unbiased again if and only if the sample size value is equal to the population value. That is unbiased. The sample variance gives an estimate of population variance as expected value of sample S, expected value, that is E bracket S squared equals to sigma for large sample size. That's the estimation we're talking about. When you do this, you get an unbiased estimate that can help you to determine that the population, in a given population, when the sample size is large, when the sample size is small, this is what we are going to get. All these things can be carried out mathematically when we have the in-class or offline, which will be expressed very well. But you need to know Excel so that when you plug these values into it, you get the mean. As soon as you sum the total, you get the mean instantly, you get the standard deviation, and get the variance instantly. The Excel will help you to get these values easily without much difficulties. It makes it easier for you to, as soon as you put the values together, you use the Excel to get the mean, get the standard deviation, get the variance in the same time without using calculators, doing these calculations. When you do this, you can put down this, but with the Excel, you put it in a Excel sheet, get the values together. Then we talk about consistency. When you're doing all these things, you ask yourself, is it consistent? It is consistent when the t, that's the sample, the statistic t, is equal to, when you sum them based on the sample size n, is said to be consistent estimator of the parameter sigma. So when you calculate all these things, you have the value consistently, the value moving in a consistent manner. And when you have the population and take a sample from that population, you do a summation of those things, it will give you a parameter, population parameter of sigma, which you take a probability of it. You are saying that all things being equal, the probability of these things you are doing will range or will move to a close to 1. That's why we are saying that the probability of everything you sum together should not be more than 1. When it is 1, it's sure event. That means it's consistent. From all what you said last time, you said that probability of a given sample equals to 1 means it's sure event. That means you are consistent. You do something, it's consistent, gives you the probability of that, gives you 1. So we are talking that when the n value tends to infinity, infinity means it's very far. The large sample size you are collecting, you cannot count it. Then the probability of that statistics phi will be equals to Tn, and Tn shows that this variable x, x1, x2, x2, xn is based on the sample size n. So that sample size is what you are now going to use to get the probability of it, which gives you 1, means that it's consistent. If it's below 1, it's not consistent, but it's close to it. That is consistent. And when you're talking about variance, you're looking at variance. If you have two variances, The other one is big and the other one is small. The variability of it is that the smaller one, the one that has a lesser variance, is close to the value we're looking at. It's telling you that the variation is not much. We can accommodate it. That is variance we're talking about. But if it's wide, you look at it that the variance is big. Can we go to production lines again? When you go to the production lines in a given factory, the variance you get, the variation you get from this machine is large. You start wondering that this machine, there could be problem somewhere along the line. But if the variance is closer, you work on this machine, you get a value. Work on this machine, you get a value. On the following day, you work on this machine, you get very close value. On the same next day, you work on this machine, you keep on having a variable. In this machine, the T values we are getting from that machine is close by, while the other one is very big. You now discover that this machine is likely to have a problem. And if the machine has not been serviced for a long time, you invite a professional engineer to come and look at this machine. The errors is giving us, the damages is producing in this machine is getting alarming. And with this, I don't think we are going to meet our target by producing what we are expected to produce and move to the sales people. So on this ground, you look at these things very critically, especially in production lines. When you look at the consistency of a machine, the variability of the machines, the 2 or 3 machines that are producing the same products, and this one you're having a high number of damages, and this one is not having a number of damages, that's variable will inform you that something is wrong. Based on that thing, you'll be able to get your answer and inform the management, this machine is due for service. Can we look at this machine? The damages we are recording on this machine on daily basis is getting high. If you trace from the machine is not that, then you trace if the product or the raw material is bad. The quality of the raw material, is it the cause of this? Or the storage of that raw material, is it the cause? You start scanning. What you are doing is scanning the environment, trying to find out where the damage is coming from. If it's drinks, you look at the leakages from the production, because you have a date on each batch of the production, line production or the machines that produce them. You look at those things. Are we recording damages on Mondays from these machines? If this machine is machine A, you look at it machine B, and you look at the production damages. From the production, you have record a lot of damages in this machine. You watch it for time, for a week or 2 weeks, you'll be able to get your data. From data you collected, you'll be able to analyze it. Just is a simple way. You say the mean damages we are getting here is high than the expected. So we cannot continue to record these damages because it's going to affect us in our production. After producing 100, we have 20 damage. That's 100 over 20. You discover that you're having a lot of damages. In a particular production of 100, you get 20. It's much. You tend to avoid it by looking at what is the cause. Statistically, we are not talking about what is the cause of this damage. And you are now looking at the consistency of that. Since it's not consistent, then the variable or the variance will now tell you that this machine is bad. We now look at this as from a different angle and see what we are going to do. Then look at efficiency of that thing. If T and T2 are 2 constants, estimators, we are looking at that as estimators now. That's what I was explaining to 2 estimators, T1, T2 are 2 estimators of a parameter, so that variance of T1 is less than T2. For that sample size, which we have calculated now, we are now looking at that the sample size n, when you carry out this experiment, you got that the T, what we experience in T, the variance in T is very small, ranging from the number of samples you collected in T. Suppose you have 10 10 in machine 1, 10 in machine 2, 10 in machine 3. And the variance, the difference you have, when we're talking about variance, is the difference. The difference you have, the main difference you have in these items, in these machines, various machines. Machine 1 is more closer to what we are looking at. The variance or the difference in them is very minimal. Machine 2 is equally minimal. Machine 3 is not minimal. So the lesser in that simple, then said to be efficient to N than N, when you look at that T3 where you have variance high, then that is the estimator of lesser variance. Variability is said to be more efficient. So when you produce something, efficient is talking about how efficient, how good you are producing those things, how good you produce those things with minimal time, not wasting time. Because if you produce something and you go back and produce another one, when you produce these items, out of 10 you produce, only one is bad. That's good one. But if you produce in the other machine, out of that you have 3 bad or 4 bad. That is 40% is damaged. So it's not a good record. So the lesser aspect of the variations is what you consider to be very good and is efficient. Look at the production of drugs, efficacy of a drug. When we say efficacy of a drug, we are looking at 99.9% of that drug, that the drug you produce can cure a given disease without having much variance. You produce this drug, amoxicillin, you produce augmentin, you produce all different drugs, and the efficacy of those drugs is based on the variability, and that variability is close by. This drug is 99.9, this one is 99.99, this one is 0.999. So this variability is close by. You discover that the difference is very minimal, and it assures you that this drug is efficacy. The efficacy of this drug is good, and the production lines are equally good. That helps you to tell the management that what we are doing is in progress. So we talk about this. That's why I'm talking about the damages. So when you have 2 machines that use in this production department, records from both sides, statistically analyze and confirm that which of the machines that are more consistent and reliable gives us the required volume. So if you are expected to produce 2,000 in a day, and that machine that is problematic, when you produce everything, you produce 100, gives you 40 bad. By the time you start from 8 o'clock to 5 o'clock, which is the closing hour, normal closing hour, you discover that the one machine that chunks out a lot of volumes that is efficient is good, is the other machine that gives you probably every 100 it gives you 10 or 5. So that at the end of the day, you discover that out of 2,000, you are recording just 10 damages. Why the other one that is giving you some damages higher is not reliable? So what you tend to do is to stop that machine from working for a meantime and call the experts people to look at that machine so that they'll be able to get these things done so that the machine will be put back in order. So another one is sufficiency. A statistics T is talking about the variability of these things. T, x1, x2, x3 to xn is said to be sufficient estimator of parameter sigma or z or q or mu if it contains all the information in the sample regarding that parameter. Thus, is said to be based on the random sample of that. So when you think about getting a sample randomly, you get to the market, you pick various things that is safe for you. When you do an estimator, that thing will give you a sufficient answer. It contains information that is relating to that, very close to the population parameter. That is giving you an idea that this thing is correct. But if it's not giving you that from the random sample you have collected, then you discover that the population is not reliable. Then you tend to see that the probability density function of that thing has to be looked at. When you look at the probability of it, you ensure that it has a sufficient estimator. It has its sufficient parameters we are measuring. Not a question of you gather it in such a way that it's not random. It looks that it's just straightforward something. But if you pick from this, pick from all the markets, somebody from the head office may ask you to give us a sample of a particular product in a place, maybe in the east. You get to the market, pick the price of those things and send to the head office. What they're trying to do is to get a sufficiency statistics in that aspect to ensure that what we are dealing with, the probability of getting this thing is sufficient estimator. If it's confidential, that's the condition. It's telling you that these things we are doing is close by. So you say that the population does not depend on that thing, but the sample you get regarding to that sufficiency or sufficient is sufficient enough to report that these prices or these product prices are in order. There's no ambiguity. There's no juggling of the figures from the sales one is bringing for you. So by the time you sample this, sample that, sample all the areas, you're able to get a close by population. So that will help you to get. Then when you talk about forecasting, time does not permit us. Forecasting can be done using a mean, using a variance. But in most cases, when you look at the time series, it gives you a good estimator. Or regression will give you an estimator that you can estimate what is happening in the market or what you can generate or the volume. If you look at the mean, you calculate the mean value of a given thing, you put it together and say, look at the mean value of this production is 6. The mean value of error we are getting on this is 6. So based on that, you'll be talking about if we are going to have a given thing, a volume, if we are going to produce 10,000, then we are looking at the mean error or mean things, damages we are going to get will be this. If we produce 100 and we get 2 as damages, then when you calculate that for a week, you get the mean error. So from that mean, you say that if we're able to produce 10,000, a volume of 10,000 items, we're going to likely to get a mean value for damage to be 10 for the month. And that will give you an idea. And the management will use these decisions to work on what they're doing. So based on that, we may be rounding up our lecture by telling you that the consistency, you look at the probability of it, it has to be 1. And the efficiency of any given item, you have to look at the variability of it, the variance of a given one plus the other one. You look at 2 of them. Anyone that gives you a lesser variance seems to be more efficient. And likewise in the hospital, health industry, if you are dealing with human beings, you don't need to have a big variation. So that's why you have level of significance for operations in the hospital to be 99.99. That's the error in operation has to be very minimal. So when you are dealing with sales in the market, the error, significant error you are thinking about is 0.5 significant error. That is 5% error because of the season, because of the variations in the market, because of variations in human beings and customers' demand for the particular products, and competitors equally in the market. So you can't determine all those things So when in a behavioral science, you look at 5% significant level. But when in the medical aspect of it, you look at 99.9%. 99.99%. That is, you are saying 99.99% confidence interval. The interval you are going to have confidence that this thing is achievable. Why in the behavioral science market, based on these things, work whenever you are talking about estimation, forecasting, you look at a close value to what you are doing. Next time, we are going to deal more on this confidence interval and estimation more and forecasting. Thank you and bye for now.